Hi guys, ready to continue in Chapter 7? We're going to take a look today at Chapter 7.2, which is about graphing quadratic equations, or quadratic functions, in standard form. So one of the things that's really important to remember is this line of symmetry that we keep talking about, because it can be a really useful tool for you. It's the part of the parabola that cuts it in half so that both the left side and the right side are perfect mirror images. This allows us to find a point on one side of the parabola and know that there's a point directly across horizontally for it on the other side. So let's take a look. So to find the vertex of a parabola, when you know 2 points, that is, we're going to try to find the middle of the parabola. We're going to try to find the vertex. So let's demonstrate here. I'm going to try to draw down here at the bottom. So if we have a parabola like this, and we know that we have a point here, we know that we have a point directly across over here. If we know the distance right in the middle, we know the line of symmetry. And when we know the line of symmetry, we know the minimum or the maximum. So hopefully that helps you understand this formula. This formula says, take the x values of the 2 points. Sorry, I wrote right over that. Take the x value of the 2 points and add them together and divide by 2, because that's how we find the middle. Take that answer that you found for x and put x into the function. That will help you find the y value or the output. So this says to do the same thing that I did, which says find the x value and then plug it in to find the y value. So let's take a look at this. We're going to sketch the graph of x squared minus 4x plus 7. First, one thing we can find is the y-intercept. When we find the y-intercept, remember that is when x is equal to 0. So we plug in 0 here. We plug in 0 here, and we find the output is y. The output is 7. So we have the point 0, 7 is where this parabola is going to cross the y-axis. So now that we know where it crosses the y-axis, let's find the point directly across from it. In order to do that, we know that the output has to be 7. Visually, you were thinking about this parabola. It's opening upward because we know that there's a 1 in front of the x squared. We know that this x, or this y-axis, is 0, 7. That means there's a point directly across over here. And that's what we're trying to find right now. So we know that the output has to be 7 here because it's 7 tall again, but we just don't know what the x value is down here. So we put 7 is equal to x squared minus 4x plus 7. We subtract 7 from both sides. We get 0 is equal to x squared minus 4x. This is where all that factoring practice has come in. Ooh, look at my writing. This is interesting. Factor. So this is why we factored here. So that way we know that the factors are where it crosses the x-axis. So my drawing isn't very good because that should come down through the x-axis. So we should actually have a picture that looks like this. It crosses the y-axis here. And there's some x-axis down here, and it's going to cross at 0 and at 4. Sorry, this drawing tool is difficult in this program, but hopefully it helps you understand. The importance of factoring is because it tells us where the parabola crosses the x-axis, and that's what we were looking to show here. So we know that now there's 2 points. X is equal to 0 and x is equal to 4 when they both are as tall as 7. So, trying to get this to move here. So now we know that we have the points at the height of 7 are 0, 7, and 4, 7. We can find the symmetrical axis, or the line of symmetry, by finding out what is in the middle of 0 and 4, because right in the middle of those 2 points will be the line of symmetry. So the point between 0 and 4 would be 2. Now we know that when x is equal to 2 is where that minimum is going to be. To find the value for y, we simply plug into every point that there was an x. And when we solve that, we find the y is equal to 3. So we have the vertex is at 2, 3. Now, that helps us to be able to graph this. We now know the line of symmetry, so we know the minimum. We knew where it crossed the y-axis, and we knew where it crossed twice at the x-axis. So that should give us plenty of things to draw. So using symmetrical points to graph a quadratic function, find the y-coordinate of the vertex. Depending on how accurate your sketch is, you may need to find additional points by simply plugging in 1, 2, -1, something like that into the original function to find other points. Now the textbook gives us a crazy example because they use a bunch of decimals, and this is just to help us understand the same process. We are going to find out how to graph this quadratic equation by hand. Finding the y-intercept, remember x is equal to 0, so we substitute in right here where x is equal to 0, we find that y is equal to a -5.7. So we know that there is a y-intercept at 0, -5.7. When we substitute that back in and we say, all right, the height, or the y value, is equal to a -5.7, what are the other x values? When we do that, you can see here that we added -5.7 to both sides, and now all of a sudden we have this crazy -0.9x squared minus 5.8x. When we factor out an x, we end up with, when we factor out a negative x, we end up with 0.9x plus 5.8. Those are your two factors. So when would a negative x be equal to 0? When x is equal to 0. When would 0.9x plus 5.8 equal 0? Well, we subtract 5.8 to each side, we divide by a 0.9, and we end up with this approximation. So we know the two x values are 0 and a -6.44. Now, if we add those two together, divide by 2, we will find the middle point. -3.22 is the x value of the vertex. When we look at that, we complete the function by substituting in a -3.22, and we find the y value is 3.56. Now we should have known that this is a maximum. Because there was a negative x squared term, we knew that the parabola would be opening down. Because of that, the maximum is the vertex. These other 2 points we found are directly across from each other, and that allows us to sketch the parabola. So it doesn't matter if our numbers are funky, we still use the same process. You can also plug that formula into your graphing calculator, and when you do so, you put the formula in your y equals, and once you have a graph on your screen, make sure that you can check the maximum or the minimum. In order to do that, you are going to press second, and then you are going to press calc up here at the top. Once you press second calc, you can find the minimum or the maximum by selecting 3 or 4. Sorry, there's a glare. Once you select 3 or 4, it's going to ask you to decide the left bound and the right bound. Just pick any spot on the parabola to the left, pick any spot on the parabola to the right. It's going to ask you to guess. It's up to you. You don't have to. You can just press enter. And then it will give you the maximum or the minimum at the bottom of the screen. And in this case, it found exactly what we found manually. So, there's a vertex formula that helps us find the x value of the vertex. When you have an equation in standard form, ax squared plus bx plus c, you can find the value of x by taking the value of b, dividing it by 2 times a, and making sure not to forget that this is a negative b over 2 times a. So make sure that you don't miss that negative sign. Then once you have the x value, you know how to find the y value or the function value. You simply substitute it in everywhere there is an x in the function. And that's what this is just telling you. So let's look at 2x squared plus 10x plus 7. To find the x value of the vertex, we take b, which is 10, we take a, which is 2, and we take 10 divided by 2 times 2, which is 2.5, and we make sure we know that that's negative. So the x value is a negative 2.5. To find the y value, we substitute it in the function, and we find that that's equal to a negative 5.5. So we now have the vertex, which is a negative 2.5 and a negative 5.5. We can find other points by just substituting x values into the function. Once we have the x values in the function, we can find the other points to sketch the graph. So just remember that if you are using the standard function, if a is less than 0, so if a is negative, it's going to open downward, so you're going to look for a maximum. If a is positive, then it opens upward, and you are looking for a minimum. So let's look at one last example, a real-life example of a firework being launched into the air. The firework is launched at a negative 16 t squared plus 200t plus 1. Let's think about this. If it is launched, if the shell is launched into the air, it's going up, 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 and then down, 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 down. Because this is a negative 16, we know that the parabola opens down, so we are looking for a maximum height. We're wondering how long did that take to get to this height? So t is going left to right. So we know that t is the time going left to right, and we're wondering how far over does it go before it reaches its height, and what is that exact height? So in essence, this problem is asking us to find a maximum. So in order to do that, let's take a look at the formula and figure out what we need to do. So we know that we want to find the time, the t value, which has been x in our previous examples, but in this case it's t. So because we knew the formula was 200 divided by 2 times a negative 16, and we know that all of that is negative, two negatives are going to give us a positive answer, which is good because we want the time to be positive. So the time is 6.25 seconds is when that's at its maximum. So we can find the height by substituting that 6.25 back into the formula, and we find it at 626 feet. You can graph this formula in your graphing calculator and find the maximum to be exactly what we found. So to understand what the vertex means in this fireworks problem is 6.25 are the seconds, and the maximum height when it explodes is 626 feet. I hope this helps you guys. I hope you're staying well. I miss you so much. Keep up the hard work. I've updated your grades, and I cannot wait until our lives can resume back to normal, but only when we can all be safe. Take care.